Okay, okay. So maybe I'll give a quick glance around what we have discussed and also a short recap also for the people who have attended yesterday. So saying that, let's get started. So I hope you have gone through the latest syllabus link, which I have posted over there. So there is a small change in terms of the syllabus which we had. So I have enhanced it by adding a few more into the total syllabus actually. So let's also see that in a later part today. Let's get started with this. So this course, as I explained yesterday as well, so this will be more into the data engineering part for Google Cloud Platform, like where we will be concentrating more on the data engineering services, which help data to be extracted, loaded, and can help in having the data hosted in maybe a database or a data warehouse, or also into a cloud storage or in any form. So let's also see much deeper into the services which help to host data. So that's something which I'll also explain into the components which we are going to deal in this particular course. So given that, I'll just give a brief agenda of what we are going to discuss for this session. Like we are going to discuss a little bit about cloud computing, its types, its service models, and who are the majors currently with cloud computing and what are the basic advantages between most of them. I'll give a course introduction, like what we are going to cover in terms of this particular course, and also a brief description around the platforms and tools which we are going to use. So predominantly it will be Google Cloud Platform, which is from Google Cloud. And also if in case, if we want to develop a solution which is code based out of ETL, we can also extend. But yeah, saying that predominantly we will see that this course covers the maximum part of BigQuery. BigQuery is the data warehouse service which comes from Google Cloud Platform. And yeah, let's look into the console as well at the end of the session. Meanwhile, if you have questions, maybe you can type it in the chat window, and we can take a logical break at some time and go through the questions together. Okay, and I maybe if people can give a single word about their expertise right now and what they are looking from this course, like as like you can give a single word from each of you saying that, oh, like why you're going for this course, like are you stepping something into data analytics in GCP, or are you interested in this? Maybe a word from each of you.
Yeah, this is Sandeep. Am I audible?
Yes.
Yeah. So I have joined regarding BigQuery actually. So related to GCP, mainly because I'm working in a product-based company, and we are going to face the customers who has
Mhm.
BigQuery. So we will be installing our product in BigQuery. So BigQuery is the main challenge. So that's why I
Okay.
joined this course.
Okay. Maybe others, maybe you can be a pretty much short saying that I want to upskill, or I want to apply these learnings at the project, or something like this.
Raghavender, Paramvar this side. I'm
Yeah.
audible.
Yes, you are.
Yes, actually, I'm working on GCP environment from 2.4 years. But to
Okay.
be very honest with you, when I was entered to GCP, it is totally new to me. But still,
Okay.
I'm not gaining that much of knowledge, to exposure properly in my every project, because just only the knowledge of BigQuery is not enough as a part of data engineering. You must have to know about the composer as well as PubSub and
True.
data flow as well.
True.
If suppose we know the basic concept of SQL, we can easily manage in terms of jobs, with the help of BigQuery. But
Yeah.
when we are talking about the Apache Airflow pipeline in Composer, or maybe data pipeline in Dataflow. That part would be very crucial. So my
Yeah.
question would be like, would you be add this portion also in this syllabus, or?
I kept it for the last week, as I have shown in one of the slide, that we'll cover a sample data pipeline using one of the code-based ETL, that is data build tool. So we can write SQL transformations in data build tool and have this orchestrated in Airflow. And Airflow you can access in Google Cloud Platform through Composer.
Composer, yes.
So I can take through that in the final session of it. Like once we cover the basics of like each service, and also going in depth into BigQuery, and then
So
later.
basically, how many services we are learning on this course? Means especially BigQuery and GCS only, or many others also?
No, I had to revamp it, at least for the interest of everyone. So I'll start with the course content, maybe the introduction to Google Cloud Platform, covering the core services at a glance, not everything into depth, but at a glance. Like we'll go in detail maybe in one session for the compute engine, Kubernetes engine, app engine, cloud functions as required. Maybe cloud functions will be really helpful if in case if you want to run some shells or shell scripts or something, it will be definitely useful in terms of data engineering. Then we'll go and look into a flavor of our storage actually. Like it can be object storage with cloud storage, block storage with disks, and relational databases offerings what we have, NoSQL offerings, and then a little bit into the networking services, and then enter into the actual big data services which we have at Google Cloud. So these are the ones. Maybe we'll have an introduction to the topic and see how it works and what are the usage of this, and go in depth into BigQuery in a later part. Also, I will try to touch up with the services which are available at AI, and also when I say we deep dive into BigQuery, we are going to discuss about its architecture, it's like the free sandbox environment which we get in, also the resources, how we are going to manage and how we are going to work with the BigQuery resources roles, working with the roles of it, and start creating tables, views in datasets, and working with external tables, authorized views, naturalized views, this kind of stuff. And basics of DML with inserts, updates, which everyone knows, but we'll also cover that. And also in BigQuery, now we have this facility to read the data from a CSV file also, which sits in a cloud storage bucket. So that's where we can also see loading data into BigQuery and how to read data, and any complex functionalities which you want to perform with BigQuery can be discussed. Some use cases like importing data from file using BigQuery interface, importing data from a drive, and batch loads with data pipelines, having that. And as I said, we can do a demo only for data build tool, like where I can take you through the way we can read data, load data into BigQuery using dbt. dbt is the code-based ETL tool which we can. And then once we have this, maybe we can orchestrate these jobs into Airflow with Composer, creating DAGs that I can show as a demo only. And also if we have code which we have built it through this process, maybe like a short demo on the Git as well, so that it covers a complete life cycle of one data pipeline. That's what the course will talk about. Any questions on this? So we are not going much into the application services, or we are not going much into the machine learning or AI capabilities of Google Cloud Platform. But of course, we can give a touch and glance to see what is the real capabilities of GCP environment. We can do that. Any others want to learn this course for some other purpose or just for upskilling?
Yeah, hi Raghavender. This is Shekhar. I have 11 years of IT experience and currently working as a lead data analyst. So basically, my profile is to I work in more into BI plus Azure stack, Azure
Okay.
Data Factory, Databricks, and Snaps, and some part of Snowflake. So recently, just I came across DBT. My interest is more into the DBT tool, and these are
Okay.
the three tools actually I was looking: DBT, Fivetran, and Apache Airbyte.
Okay.
So,
Okay.
so more into ELT tools. So I came across this course in the DURGASOFT and just want to know about more into DBT and
Okay.
plus GCP, how it will enhance my career. That's my question to you.
Okay.
Because I am already into Azure platform and now
Okay. Okay.
learning GCP with DBT, how it will support and whether it's a good decision or not, that I want to know something from you, Raghavendra.
Okay. Okay. Like for your question, maybe I can answer. So if you see data fusion is the part which is the right ETL tool, like you can say it as ELT as well, but this is the one which can read data, write data, and transform data also. So this part. So for Google Cloud, data fusion is still evolving. Google Cloud Platform, this product is still evolving. When you compare to its peers like AWS and Azure, in Azure, Synapse Analytics is a little advanced, I would say, and compared to the data warehousing services at Azure and at BigQuery, the performance of BigQuery is very much lauded about, very much talked about also. Because of that, we see many majors, retail majors, as well as a lot of clients moving towards BigQuery. So when it comes to BigQuery, like most of the recent lift and shift projects happen from Teradata. Basically, the projects data warehouses which were sitting in Teradata are getting moved to BigQuery. That's one. Flavor of projects which we have recently observed, and the ETL through which the ETL which is used for this is not mostly the data fusion or not mostly the data flow, but it is mostly a code-based ETL in the real-time implementations, which is right now. So when you go to code-based, as you said, there are many, but DBT is one which is really pretty much simple and very less to learn and more to code actually. So it is like working with sources, working with models where you define how a model uh, can be written, and it's just a simple selects you right over here and define how you want to read the data from the source and have it loaded into a particular target. So pretty much simple. If you are a ETL guy, you can pick this up within a few days. It's up.
So, just question, Raghavendra. So you will teach in the CLI, not the cloud based. Sorry, the GUI based, right? Like DBT, Jinja, analysis, docs, cloud features, seed sensors, all this
So
concept.
I can work on this Visual Studio to get this DBT installed, and maybe it should be the CLI version itself, not the web version.
Version. Okay, okay. Yeah. How about the Jinja and seed sensors, materializations in DBT? Will you
No,
cover
no,
that?
no. It will be very basic into DBT.
Okay, okay.
Okay,
At,
and this I will also show it as a demo, not explaining much into the DBT part, but I'll definitely clear if you have any questions or anything. Provided that I will also give you an installation document how you can proceed with DBT on your local, because this is a freeware.
Yeah, so just one question more, Raghavendra. So if suppose I'll use this, I learn this course and can I put in CV that I work on data build tool, some of the case studies, at least some kind of experience? Can I get confidence
So
using?
data build tool in order for you to reach that confidence level, I think only complex things comes into the projects is when you had parameterization into it. So only thing which can grow complex for any solution is that you might need to read in parameters. You might need to you might need to have it packaged rightly so that you can move between various environments. So that's the only complexity I see. Or else rest all it has very minimal Like you don't have any transformations like a GUI tool. You write the SQL over there, and based on the SQL, you mention what would be the source, what would be the destination, and you write all the transformation logic in a SQL basically.
Okay.
So that's pretty much simple. Even we can go through that.
At least you can show end-to-end flow, right? Using DBT.
Yeah.
Okay.
That's true. That's true. And any other questions from any
And
other participant?
Raghavender, if I know only means SQL common commands I know, but not like a joins and all. So is that efficient for BigQuery and all?
For BigQuery, at the moment, if you know SQL to the extent of creation of tables, to the extent of selecting data, to the extent of inserts, updates, if you understand this, that is enough, and we'll cover a lot, at least in BigQuery.
Okay.
So, and at the end of this, you might be pretty much comfortable coming to BigQuery, and also what service you can choose in Google Cloud Platform when you have this kind of requirement to have data pipelines, or to read data, to load data, or to work with huge amounts of data. But I would definitely not recommend when you have huge data to be ingested, data build tool is not the right tool. So please always remember, for transformation data, for code-based ETL works actually only for transformations. When it comes to data ingestion, you need to see what is the best way. So even that needs to be addressed actually. So nowadays, most of once with the buckets in the cloud storage, and also with the other cloud service providers, you have a kind of data lake already sitting in the cloud storage buckets actually. So from here, most of the analysis work is also happening. So like now, the days where we had this raw layer, which was traditionally RDBMS, is now gone. So at least we are able to see the files sitting in a certain specific delimited format can also stay in your cloud storage buckets, where you can place it, have it versioned, and have it read like a data lake. That's also possible. Okay, so if no more questions, maybe we can get further with the introduction part. Someone had some question?
Hi, Raghavendra, Ram this side.
Hi, Ram.
Actually, my technical skills are like I'm part of integration. So I just got a chance of to consume one of the BigQuery service. So I'm interested in because of that. My question is like you just said, like with the basic SQL, we can go ahead with this, right? So is that okay to face interview and project point of view?
So with this course, you should be comfortable to speak about the services first, and when it comes to BigQuery, you should be able to at least speak about what all you can do in BigQuery at the end of this course. And if you want to crack a particular interview, I would say we might need to take ahead and go much deeper into the services, what is available, and also go through the frameworks. Right now, data pipelines, if you start with, if you want to give an interview, which is more into the technical architecture of data flows, which happens in Google Cloud Platform, you might also need to explain about the raw layers as well as ingestion layers, like discuss about how ingestion happened and how the transformation layer was, how there is also a preparation layer, which is a kind of target layer for the tables, where you have the model loaded. And then you have the consumption layer. The consumption layer is where you have the views which have the security, so that their reporting tools can pull the data from. So maybe if you have that whole idea, I think you can crack the interviews.
So these and all we can discussing as part of this course, right?
Yeah, at least in the final week, I would give real-time exposure into this, but because once you know each service, only then you can really correlate. If I start
Yeah,
explaining a project,
okay.
then it is better that you should be able to figure out which service goes into which part of the data ingestion, data pipeline, and in the life cycle of data pipeline, which service can be useful. So this kind of information should strike in your mind once you know a particular service. So uh, I can explain and take you through the services, but yeah, we can also discuss about few use cases in the real time, how currently a few projects are there. So from that, maybe you can start exploring and give interviews.
Okay. Yeah.
Okay. So, okay, maybe if there are no questions in this topic to be covered, maybe I'll go a little bit on this introductory slide, which we covered a little bit yesterday. So we are going to discuss a little on the cloud computing types and platforms, which we're going to discuss about. So about me, I'll okay, a small glance. So I have near to 15 plus into BI and data management from the starts. Like I worked with all the traditional ETL tools, GUI tools, as well as I worked into reporting as well. So I'm Google Cloud Platform certified, and like my interest is more into data ingestion, part transformation, and visualization. I I worked into data profiling, data movements, like when it comes to reading, loading, and transforming also, and also the ETL architecture as well. So currently I work with the cloud transformation project, which deals with data movement, code movement, like having the jobs orchestrated from a Teradata-based data warehouse to a BigQuery-based solution. So I also worked with two major BI transformation projects, which had this lift and shift, where we had moved the infra from on-premise onto cloud. So if you have some questions, maybe you can put it in the chat, and I'll go through the basics of cloud computing. Maybe for people who attended yesterday, it might be a repeat, but I can go a little faster without boring you. Okay. So cloud computing is essentially a service which comes from the cloud service provider, which is based on demand. When you request for some IT resources, you want to access it through the internet, and you want to use it and pay it for the ones which you have used. So it is going to relieve you from this overhead of buying, owning, maintaining all these physical data centers which you earlier had for your organization. That's something which you're going to save in terms of that initial costs. So, but your maintenance costs are going to be billed as per your usage. So you will pay as per your usage, which means that your regular maintenance costs will be high compared to that of on-premise. But on-premise, please remember, it will always have an initial cost. So you can access your technology services through internet. It can be anything. It can be any kind of service. It can be a computing power. It can be a storage service, or it can be a database service. So depending upon your requirement and as needed. And it is always provided by a cloud service provider. And we know there are three majors, but we also have a few more in the market already. So based on deployment and based on service model, we can have cloud computing two types. One is based on deployment, where you have a private cloud, a public cloud, and a hybrid cloud. And also recently multi-cloud. You might have seen a scenario where there is multi-cloud, like we were discussing yesterday, where the data warehouse was hosted in the cloud data warehouse of Snowflake, but the files were hosted in AWS cloud, is what I understood. So when you talk about a private cloud is an environment which is set up by the organization for its purposes with the cost of its own. So it is like you have an office premises which you can call it as a data center, and you allocate a physical building for this private cloud, and you purchase all the equipment like HDD, power generators, and initial investment which that goes into the data center. You have internet connections connecting this to the major, um, and there is a lot of initial cost which is assigned to it, but you have the highest security around it, and you have the overhead of maintaining everything, starting from your network connectivity to upgradation of your servers. Everything, all these will sit on the organization's head. So when you go with the public cloud service provider, so the cloud service provider is something he is going to offer cloud services, and he is also called as the cloud service provider. He will be providing services, many services. It can be data services, can be storage services, it can be infra, it can be, and like the AI services which we have discussed, many things. Like these will be something which will be physically hosted by the cloud service provider, but we will be using it through the internet. And like, as you know, you might need to pay for the service what you're going to use and what you're going to request for. So there is no initial investment for this, but only you might have monthly expenses. Like you mention a billing account and have it billed over there. There is an hybrid model where you have your on-premise, you want to maintain it because you have had a lot of investment into it, and you also want to use the public cloud whenever you have a huge demand or whenever your server is going above the limit. So it combines both the public and private cloud, like where your on-premise can host your critical applications and have the really sensitive data sitting in it, and have this public cloud processing some jobs which are performance intensive or memory consuming. So these kind of use cases you can use for this. So this can be a flavor, but also remember, in the hybrid you might still have this headache of maintaining the on-premise. There is a fourth part in the deployment, which is a multi-cloud. So nowadays, based on the services provided, you get you get a best service from one of the cloud service provider. You get another database service, which is much better, much grown, and much evolved in one of the cloud service providers. So you want to use storage from Google Cloud, and you want to use data services from Azure, and you want to use maybe another service from AWS, it's still possible. You have this Anthos environment, which can really do the orchestration as well between multi-clouds as well. So that's something based on a deployment model. Let's see, based on the service model, you have infra as a service, platform as a service, software as a service, and these are well-known terms, as you know. So whenever you see, maybe there is a next slide which gives more information around it. So I'll explain a little later on this. And if you see the times when these cloud service providers started, AWS is relatively in the market from very long time, and the customer base is also very high. And when you compare this to Google Cloud, which we're going to learn, it is slowly growing but steadily. And the product offerings which Google Cloud has currently is like especially BigQuery, and also the pricing model is much favorable, which is really adding to the growth of Google Cloud Platform. So when, as I said just a while ago, like you can have this classified into these many types, like where you have infra, storage, platform, database, function, and software. Software as a product itself, which you can use as a Google Suite or as a Office 365, like many things. You have this cloud data store, DynamoDB, SQL Azure. So this kind of services is something which comes in each of the service models. So when you also check into what's doing better in cloud infrastructure and platform services, this is the Magic Quadrant which Gartner has published in late 22. So it discusses more about the completeness of vision versus the ability to execute these cloud infra. So AWS and Google, AWS, Microsoft Azure, and Google are the leaders in this. So, and slowly Google is picking up in the recent past. And this is also just a view about the comparison, how the overall rating is there from Gartner. So it is also favorable for Google Cloud Platform for its infra, especially, and also on the pricing part. So when you see the products, services, the services which come from Google Cloud, majorly we can start with looking at compute services, what kind of compute services we have, and storage services, storage and database services, as I shown you in the course manual, like object storage, block storage, and database storage, which you can classify, and the networking services between the Google services and also to the external clients. And identity and security IAM is one which ensures the security between the services in Google Cloud, and also ensures that there is proper security for the external traffic as well. And you have Cloud AI as well as IoT service offerings from Google Cloud, which are a little advanced topic up and above this course, but maybe we can check into a few basic services for this. So predominantly we will be discussing in our course on the big data part. When you say big data part, you talk about more about the analytics part. So that's something which we will be discussing. There are management tools where you would like to know what kind of logging or what kind of tools which can help you to manage billing or manage your resources, like administer the services, how the services uh, are logging their logs, and how you may be creating dashboards around the services performance, usage, it's CPU usage, it's anything which is consuming a lot of resources. This kind of things can also be tracked from Google Cloud itself. So when you talk about what Google Cloud and a little brief history about Google Cloud Platform. So this is a suite of cloud computing services which runs on the similar infra that Google has. Google uses internally. So it is the best quality of computing services as well as storage and all platform services which Google Cloud Platform offers, which Google itself uses. It's a subset of Google Cloud, and it's been launched in 2010 as a individual services. But by 13, we have this complete service platform as together, like with few services like App Engine, Compute Engine, as well as part of storage in it. So now currently, Google is grown very much into more than 100 plus services, which span across many areas which we have just discussed, maybe a big data or a networking, computing, and much more actually. So it has presence in 37 regions and 112 zones. It also has an advantage by having this 1 year and 3 year long-term pricing models where you can commit upfront what will be the usage, and then you you have discounts which are applicable. And especially to the compute power, when it comes to workloads, you have a 57% savings compared to other cloud service providers. So where you can use these cloud service providers is depending upon your customer requirement. It might be a lift and shift project or a refactor project, re-platform project, and rebuild or replace. So these can be a five cloud transformation projects which you can work, which you might have an option to work, because right now, if you see, like majorly depending upon, no one wants to replace every application and go for rewriting the code completely. Maybe a soft forklift of the current services onto Google Cloud, having it lift and shift, and having it run on the cloud infra is something which is a very basic cloud transformation project. And you have this refactor and re-platform as well, which will take the advantage and benefits of the cloud environment. If there is a native cloud native service you want to use instead of the erstwhile uh, customer application, then that's possible using this. So let's talk about a little bit more into Google's regions, zones. Okay. So when you talk about regions and zones, maybe you might need to understand the geography. So the whole geography, you have regions, and each region will have zones. Zones is kind of a data center actually. So current region with 3 zones is something which is a dark blue, and a dot with white is something which is a future region zones. And Google has a lot of point of presence, it is well connected with edge point of presence as well as CDN point of presence, where its network is connected around the world and the best, as you know. Okay. And okay, Google Cloud offering. Let's see about the complete list of Google Cloud's offering. This is the categorization of all the services which we currently have. Majorly, you should say, if it comes to compute services, we have these storage. I'm not sure if you're able to see this, but this is the complete 100+ list which I was talking about, and there might be few more which might be added also. But yeah, it's a very huge list actually. Out of this, you might need to pick in wisely what to learn and what you can use really. Like taking an example of data analytics, you have BigQuery, BigQuery BI engine, BigQuery ML. Please always remember why BigQuery is in the market. BigQuery is in the market because right now you have this additional ML capabilities inbuilt in BigQuery data warehouse that is enabling data scientists to have run their models directly on the BigQuery data warehouse. Ideally, we used to have a separate project which used to connect to data lake and do a lot of machine learning around the data lake to have it ingested, transformed, and like it was a different thing. But now you have ML capabilities sitting within BigQuery. That's an added advantage. You have Cloud Composer, Cloud Data Fusion, which are going to orchestrate and also have the data pipelines designed. So that's something which we will discuss a little in detail. And we have data flow, data proc, data prep. Data proc is the Hadoop flavor of Google Cloud Platform. You can implement Hadoop cluster in data proc. You have PubSub, Cloud PubSub. It is the publishing and it's a subscribing Kafka equivalent, where you have a topic, you can publish messages on the particular topic, and you can have subscribers reading those messages. This kind of stuff can be done from Cloud PubSub. And you have Data Studio. Data Studio is now Looker. Looker is the reporting tool. You can visualize any kind of reporting, any kind of self-service reporting or any dashboarding which you have using Looker. And the best part is you can also directly start using a query set, a result set based out of BigQuery in Looker. So BigQuery in its console is having a connection where you can start taking the data of the query and having it getting visualized. That's one of the advanced feature which is present in the BigQuery console. So I'll go a little bit out of this page because this looks big and little difficult. But maybe coming out of the topic, I would like to show a little bit on the sharing. Sharing part. When you say sharing, it is about how each of the service which are between cloud service provider and the consumer, like how the shared responsibility is being, how the responsibilities are shared between the cloud provider and the consumer. Like when it comes to when you start from the bottom, storage, networking, and compute. So these are the basic parts, basic offerings which any cloud as a service, any infra or a platform or a software. So these services are the very basic service where you have a storage, a compute, and a networking. You have storage and compute power and networking, which is common across these three. So the basic service which a cloud service provider as an infra as a service provides is this. So this, when you go for infrastructure as a service, maybe you want to spin up a virtual machine. So you want a compute power, you want to compute with a certain machine types and have a certain storage and have the right connectivity to it. So this is what you talk about as an infra as a service. So in this case, the blue highlighted part, which is something managed by the cloud service provider, and you manage the machine operating system you want to install on the machine, and you want to maintain the runtime on it, as well as the applications which you want to have on the virtual machine, and also the data and access you want to control out of it. So this is infra as a service. When it comes to platform as a service, so you want to use the infra from the cloud service provider, and also you want to push some of your responsibilities related to OS patching, also related to the virtual machine settings, and like runtime related upgrades, as well as everything. You want basically have a platform as a service where you can put your applications and data and access and control the access around it. So the responsibility of data and accesses, like the security around the data, is something which you might need to manage. And when it comes to networking, storage, compute, operating system, all these will be maintained by the cloud service provider. And you have the typical example for this is you want to host Cloud SQL. Cloud SQL is an offering from Google Cloud Platform, where you have three options. You can choose any one of the database, maybe Postgres, MySQL, and SQL Server. And then you can start using this database, like creating your applications on it. But definitely, a part of the maintenance of the database is shifted towards the cloud service provider. And when you come to software as a service, so you just want to concentrate more on what you want to develop and what data you want to deal with, and how and who can access on it. You don't want to worry about anything about the applications, runtime, nothing. So you just want to use the service. You just want to use a data warehousing service called BigQuery. You just want to create a table in it. You don't want to set up any database server. You don't want to give archiving strategy, or you don't want to give, everything should be managed by the cloud service provider. You just want to work with your data sets, which is a kind of a schema We want to set up a schema, put your tables, and work with your views, and like have the data loaded in it. So that is a software as a service. For this, the typical example is BigQuery. You don't need to set up a server for it because it is fully managed service from Google Cloud Platform. So let's dig more into what services we are going to cover in a deep. Maybe when you come to storage, like Bigtable, cloud storage, Cloud SQL, Cloud Data Store. Coming to the compute power, you have App Engine, Compute Engine, Container Engine. We'll go deep into each of this topic for one subject area, maybe storage on a one day, compute on a day, and each of this service in a big data, we will take it one day, having a description around it and doing a demo. And also maybe if you can really spin up your Google free account, which is valid for 90 days and with a credit of $300, which is given automatically to you by Google whenever you opt it, so that we can also practice. Also, we'll cover into identity and security part, and also management console like cloud console, logging, and monitoring. So one of the person was asking about how the life cycle of data engineering can go. So you can briefly looking at this picture. I'm not sure how much it is visible for you, but you can classify the products or the services which Google offers into storage services like ingestion services, analytics, machine learning, and the ones which serve data in terms of reports. Data Studio is a erstwhile, always remember it is now Looker, and we have Dialogflow and App Engine as well. So cloud storage, Cloud SQL, the advanced version, which is which is more spread across multiple geographies, is the Spanner, and Cloud SQL and Spanner are the relational database versions. And you have the ingestion part where you have data flow, which is kind of ETL, but works with Spark. Composer, Cloud PubSub, as we discussed, is a streaming service which we have from Google Cloud. You want to run some functions as a service, then you have Cloud Functions. So this can also be used as an ingestion. For analytics, you have BigQuery, where you can use to host a huge amount of data, and also use for processing data when you are transforming data. And Cloud Data Proc, as mentioned, it is the Hadoop flavor of Google Cloud Platform. There are machine learning services as well, which we'll discuss with the basic ones. So we'll take the small overview into few basic services which we have at Google Cloud. First, storage part, and maybe we'll take some questions in the later part today, and then close for today. So you have cloud storage. Cloud storage is like the storage bucket which you have in Google Cloud, where you can store objects. So this is a place where you can put some files or images or media or anything. Like you want to store something which is really useful for you for your project implementation. So basically you have buckets. You can create buckets in cloud storage. You can organize using buckets and have expiration rule, as well as you can also define whether you want to have a cold access, hot access, or what kind of access you need on this particular bucket is also something which you can define. Cloud SQL and Spanner are the relational databases, and these give you the option to explore if you want to implement any relational database in Google Cloud Platform. You have this option, and difference between this is Spanner is more global. It can be across multiple geographies, and its reach across the globe is very high. So there might be few services that in a few regions you might not see Cloud SQL services, but it's not the case with Cloud Spanner. And also, yeah, it's a petabyte scale. You have non-relational data services like Google Firestore, Google Bigtable, Cloud Bigtable. So these are good for NoSQL actually. And yeah, you have any requirements for IoT or ad kind of thing, you can use it. And the only one offering which you see for warehousing is BigQuery, where you want to implement an enterprise data warehouse. For analytics, where you want to have a reporting tool which can have a good insights around your data collected across a certain period. That's where BigQuery is going to help you. So this is just a quick glance around the services we have, but we can go much deep into these service each when we reach to this slide. Okay, so that's something which I had for today. If you have some questions, maybe we can take and close for today.
Yeah, this Sandeep here.
Hello.
So
Yeah.
just I have questions like is it valid or not? But I'm asking. So how much complexity of the BigQuery in our course as part of engineering would be covered? This is first question. And are there any prerequisites to learn BigQuery? And how many years of experience I can gain, or else how much confidence I'll be getting after learning this course? And will any support will be provided after completion of the course in our project? So these are the questions for me. Yeah.
Firstly, we are not going to deal much into Cloud SQL, Cloud Spanner, or any NoSQL databases, but we can definitely discuss into what these are going to do, and where you are going to use it, because you can't propose BigQuery for everything. Okay, so if you have a requirement where you want to host some flags or something where the data is very less in one of your application, then BigQuery is not a solution in that case. So at least in that case, you should be able to propose at your project site that maybe if the data is already implemented in one of the databases which is offered by Cloud SQL, you should be able to pick this. But for me, since we are going in depth into BigQuery, every option of BigQuery will be discussed in our course. So I mean to say, you will be a BigQuery expert. And you might have seen some time back how Teradata was been ruling the market in data warehousing. Even now, Teradata has its footprint in terms of its cloud solution as well, Teradata Vantage. But BigQuery, in terms of its parallel processing as well as its speed, is grabbing a lot of market as well. So this we will hear a lot in the next few years, BigQuery. So that's the reason I started with a specialized course around BigQuery, having code-based ETL, because definitely no client would definitely want to go with another ETL tool opting Google Cloud Platform. And of course, there might be a question with many people: why not Cloud Fusion or Data Fusion or Cloud Data Flow? So there are many requirements which might enable, but when comes in terms of ETL, which Data Fusion and Data Flow offer, there is more maturity needed actually in terms of the solution. That's the reason you might have seen, without any extra costs, people go for code-based ETL when there is a lift and shift project in the recent times. So to answer your question, we will cover a lot of BigQuery. All options of the BigQuery will be discussed in our course.
Okay. So after this course, we can also segregate which data we can choose which service, right?
Yeah. If based on an application, like we will do that on the last week also. I will give 10 to 12 use cases. I'll not show I'll not show the answers for it, but I would like everyone to guess and give me what would be the service and where would be the service. Like if you have 3 services to use, maybe I can ask it right away. If you know a little bit about a streaming service called PubSub, can you tell me where you can use it in the data flow pipeline? Is it before the data warehouse or after the data warehouse?
Before the data warehouse.
Yeah. So you should also know the order of the service as well, which is very important. And yeah, basically you can get a glimpse around each service where you can use it and how you can use it also. Okay, so saying that, I'll close the session for today and we can connect tomorrow.
Yeah,
Thank
Raghavendra,
you.
just one small question. Just
Yeah.
1 minute. So means after just want to understand, so the whole architecture, Google this BigQuery. So after dumping that one, where you do, suppose I want to dump into in the if we say for the gold layer terminology, and if I put it into the Snowflake data warehouse.
Okay.
Okay, after cleaning up all these data transformation, all these things. So
Okay.
where
Okay.
to go? So is it possible, right?
If I understand your question, after transformation, where you want to store the data? Is
Yeah,
that the question?
yeah.
So BigQuery will have data sets where data sets is logical grouping of your tables. You can simply say a schema in Oracle. Schema is called as a data set. Data set is where you place your tables in a particular project. A project will have data set. A data set will have tables and views as per your requirement. And
Okay.
then once you have the tables, I think you should have a data model around it. So that's where your it can be any kind of model. It can be a dimensional model or it can be a data vault model. You can implement vault as well. So it's up to the data modeler how he designs it.
And after
But the
that, I
storage
can.
happens in BigQuery.
Okay, and that BigQuery I can connect with any BI tool, Tableau, Power BI, or Looker, and for visualizing to the
Yes. If
stakeholder.
you have seen, and if you have been working in any reporting tool of recent, you might have
Yes.
seen BigQuery connector
Okay.
from your reporting tool.
Okay.
There will be definitely a BigQuery connector.
Okay.
Okay.
Yeah. Fine.
So
Fine,
then we
Raghavendra.
can have a nice evening. Take care. Bye-bye.
Yeah. Thanks, Ravan.
Thanks, Raghavender.
Thank you.